Intermediate Algebra for Statistics, Section 1.4, Part 1 of 2, Approximate Linear Relationships. Lesson objectives. Number 1, use linear models to make predictions. Number 2, state if a prediction is a overestimate or underestimate. Lesson objective number 1. Example 1. The average ticket price for the top 50 grossing concert tours are shown in Table 45 for various years. Let P be the average ticket price, measured in dollars, at T years since 1995. Sketch a scattergram of the data and draw a line that comes close to the points of the graph. So here's our data. We have the years. We're going to change the years to a new variable called T, number of years since 1995, and then we have our dependent variable, average ticket price. So the first thing we want to do is we want to list the values of T. We're going to call this table 46. Is 3 would mean 3 years after 1995, which is 1998. T4 would be 1999. 6 would be 2001. We'll sketch the scattergram. P is our dependent variable, so it's going to be the vertical axis, and T is the independent variable, and that's going to be our horizontal axis. So here we have our T-axis, our P-axis, the units are given, and then we have our data, and then we draw a line that comes close to the data. Now this line doesn't have to touch any points, but it should be close to all of them. And here's an example of how you can have some different lines. Now later in this course we will use technology to compute what's called the line of best fit, and that is the line that will fit the data the best. Now let's quickly review how to use the TI calculator to graph scatter plots. So using this example, the first thing that we want to do is we want to hit the Stat button. Your screen should look like this. We're in Edit, so you hit Enter. Enter in the data. For this example, T will be in list 1, P will be in list 2. Next you hit second and Y equals, which is stat plot. Hit Enter. If it's off, make sure you turn it on and make sure it's in the scatter plot. You want to make sure that your X list is your independent variable, list 1, your Y is list 2. Now you hit zoom, and then if you remember, number 9 is zoom stat. So scroll down to 9 or just hit the number 9. Now you have your scattergram. Example 2. Use the scattergram of the linear model in the previous example to estimate the average ticket price in 2000. Number 2. Use the linear model to estimate the average ticket price in 2003. And number 3. Use the model to predict in which year the average ticket price will be $100. Here's our line. So for number 1, the year 2000 corresponds when T is equal to 5, because 2000 minus the number of years since 1995 is 5. So if we look at the blue arrow, when T is 5, we have our predicted Y being 42. So how we would interpret it, we would say, according to the model, the average ticket price in 2000 was approximately $42. Number 2, the year 2003 corresponds to T equals 8, because 8 years after 1995 is 2003. So if we go to the green, when T is 8, we have a predicted Y of 55. So we would interpret this as, according to the model, the approximate average ticket price in 2003 was $55. Number 3, red arrow shows that the output P equals 100 This time we're given a P, and we're estimating the T, and it looks like about 18.5, 18.5, or close to 19. So we say, according to the linear model, the average ticket price in 2014 will be about $100. We create a scattergram of data to determine whether relevant variables are approximately linearly related. If so, we draw a line that comes close to the data points, and we use the line to make estimates and predictions. It is a common error to try to find a line that contains the greatest number of points. However, our goal is to find a line that comes close to all the data points. For example, on the following slide, even though the blue line does not contain any of the data points shown, it fits the complete set of data points much better than the red line, which contains 3 data points. So here's the visual. The blue line is a reasonable model for this data, even though it does not contain any of the actual data points. The red line contains 3 actual data points, but it is an unreasonable model. Lesson objective number 2. It is also a common error to confuse the meaning of data points and the points that lie on the linear model. Data points are accurate descriptions of an authentic situation. Points on the model may or may not be accurate descriptions. Suppose that an independent variable t and a dependent variable p are approximately linearly related. Then, if a linear model is below a data point AB, the model underestimated the value of p when t is equal to a. If the linear model is above the data point AB, then the linear model overestimates the value of p when t equals a. Now this sounds very, very confusing, but we'll look at an example and this will make more sense. In example 2, we estimated that the average ticket price was $42 in 2000. The actual average ticket price was $45. Determine if the estimate was an underestimate or a overestimate. Number 2, we estimated the average ticket price was $55 in 2003. The actual ticket price was $52. Determine if this estimate was an underestimate or overestimate. Let's look at a visual. So according to the model, when t is 5, the model states that p is 42. The actual value was 45. In this case, this was a underestimate. The actual data point is above the line. When t is equal to 8, the model predicted p to be 55, but the actual value was $52. So since the line is above the actual data point, this is an overestimate. So if the line is above the actual data point, it's an overestimate. If the line is below an actual data point, it's a underestimate. Let's use this same model. This was the average ticket price in the year 2011, and according to the top 50 concerts, the average ticket price was $84.92. Now let's see what the model predicted. So in 2011, that is 16 years beyond 1995. So when t is 16, the model, the line is predicting, looks like about $89, $90. We'll say 89. Now if we take the actual data point 84.92 and we subtract the predicted 89, we get a negative 4.08. Now what that tells us is the model overestimated by $4.08. Thanks for watching.